We have already discussed the concept of representation of a vector in 2D, 3D. We have also discussed about the direction ratios and direction cosines in details. Now, this session I will be discussing the concept of position vector of a point. What is position vector? Imagine there is a point O and there is another point P. We take O as the origin, the reference point. Then position vector of the point P going to be the vector joining O to P. Okay? So position vector of the point P is OP vector, where O will be treated as origin. This origin in our problem solving session may be in the plane of paper, it may be outside the plane of paper also, anywhere. But if we say that position vector of a point P, then from that origin to point P, if you join, that will be position vector of the point P. Just for an example, I tell you, let position vectors of the points A and B be vector A and vector B respectively. Then what do you mean by this? It means there is a origin. With respect to the origin, if we join the point A from the origin, then we get vector A. From origin O, if we join the point A, we get vector A. Similarly, the point B, its position vector B means from origin to B, if we join, we will be getting vector B. In a particular problem, only one origin will be there. It may be anywhere in the space or in the plane of paper. So, if we say that position vector of the point A is A, it means OA equal to A vector, and position vector of the point B is B means OB equal to B vector. Origin we need not mention always, wherever it may be, but from origin to the point A, if you join, you will be getting vector A. Origin to point B, if you join, you will be getting the vector B. So in our problem, this one is B and this one A. Let us calculate the position vector of a point which lies on AB. You join A and B. I draw this line segment only. P is a point on the line segment which divides AB in the ratio m is to n. We want to find position vector of P. What does it mean? From O to P, same origin, if you join, then this vector is the position vector of the point P. OP equal to R. This is position vector of the point P, where P divides, or you assume, let P divides AB in the ratio m is to n. We are going to find section formula, that where a point on the line segment joining two given points or given vectors will divide it in certain ratio. m is to n. Now, how to find? How to find the vector OP. O is the same origin for one problem, one origin. O is the origin. You find the position vector of point P. It's very simple. If you have considered vectors over there and a vector triangle or two triangles you observe there, then first tell me one thing. In this triangle, what is AB vector? In triangle OAB, what is AB vector? We apply the triangle law. OA plus AB equal to OB. So AB equal to what? AB equal to OB minus OA. What is OB here? That we have taken position vector of B. What is OA here? Position vector of A. So we can write this one as B minus A. That is position vector of B minus position vector of A. This second point comes first. So if you want to write an arbitrary vector PQ, then that PQ can be written as position vector of Q minus position vector of P. Okay? PQ vector is found. Now here AB vector we got B minus A. We are going to find the position vector of P, which divides it in the ratio m is to n. To find position vector of the point P, we observe that AP and PB are collinear. They lie on the same line. They have the same direction also. If you put arrows over there, AP and PB have the same direction. Now, P divides AB in the ratio m is to n. So, we can write AP is to PB equal to m by n. Cross multiply n into AP, m into PB. But so far we have considered scalars only. That AP and PB, these are two scalars. Can I put vector over there also? We can, because AP and PB have the same direction. As AP and PB have same direction, AP vector and PB vector have the same direction. It means if we want to write AP vector, it will be AP multiplied by unit vector. Say I am taking n cap in the direction of AP, not AB. So this will be AP equal to AP into n cap. Can't you write PB vector the same manner? PB vector will be what? PB into n cap. What is n cap here? N cap is directed along AB, AP or PB. Unit vector, its multiplication won't change the magnitude. Okay? Now, if you take the vector sign on it, then it's fine. So you can write this one as, since they have the same direction, n into AP vector, m into PB vector. So n into, what is AP vector? See the diagram. AP vector is what? Position vector of P minus position vector of A. So you write position vector of P minus, and what about PB vector? m into the last point. The second point comes first, position vector of B minus position vector of P. So what you get finally? See, this one A, B and P is here, taking the same diagram here. Then you have taken position vector of this point A, R and this one is B. Origin is there. Now position vector of P is what? This you have taken R. Okay. This one you have taken B and this one A. So this n into R minus A will be m into B minus R. So this implies n into R plus m into R equal to mb plus na. So R vector is going to be mb plus na by. So in vector also the relation is like section formula you got in coordinate geometry. Okay. So any point, if you know this point, this vector A has position vector of A, B has position vector of B. If you want to find the position vector of a point which divides in the ratio 4:1, then this point's position vector you can write OP vector equal to 4 into B plus 1 into A by 4 plus 1. That is A plus 4B that divide by 5. Now, this m and n may be 1:1 for if P be the midpoint of AB, then what do you write? Then position vector of P will be 1 into B plus 1 into A by 1 plus 1, that is A plus B that divided by 2. Clear? Hope you have understood the concept of position vector and the section formula. Now let us, this session is not problem solving one, but I would like to discuss one very interesting and elementary level problem with you. See the application of vector in proving the theorems you have already done in mathematics before, class 9, 10 level. Okay? Suppose you are going to prove that in triangle ABC, MN equal to half BC. What is that? That triangle ABC you draw. MN I have not mentioned yet. M and N going to be the midpoints of two sides AB and AC. This part is M and this part is N. If you join, then you can prove that MN is going to be parallel to BC and half of it. So they are obviously parallel if you get this relation, because MN and BC have the same direction, or you can say that MN vector and BC vector is one of them constant multiple of the other. You can write MN half BC or BC twice MN. Okay? Now how to prove this? We can prove it just by using the concept of position vector. I am not taking the help of any concept of that area of triangle, parallelogram which we have used before. See how to prove this. For proving this, we take, let position vectors of three vertices be A. B has position vector B and C has position vector C. It means there is origin, from origin to A if you join A vector, B if you join B, and C. I am not going to join, I am not going to show you the origin even. But proof can be done. See how to do it. So if you have taken the position vector of this point A, B and this one C, then position vector of M, midpoint formula you have learned in vector, position vector of M will be what? That will be by midpoint formula A plus B by 2. Position vector of N will be what? Position vector of N going to be A plus C divided by 2. Now, what is Mn vector? Mn vector will be position vector of N minus position vector of M, that is A plus C by 2. So this will be C minus B divided by 2. Alright? But C minus B is what? In this diagram, what do you observe? C minus B means C is what? Position vector of C minus position vector of B. So you can write this one as BC vector. The concept we got, BC vector is what? Position vector of the second point minus position vector of the first one. So Mn vector, what have you got? Mn vector is BC by 2. It proves two things together. What are those? That Mn is parallel to BC and Mn is half of BC. Okay? So by vector, if you do it, your calculation will be easier, and what to say, it is more clear than any other method you have learned before. It is vector algebra and treating the problem of geometry. We will be solving many sums in future based on this concept. Right now, we learn the position vector of a point in two-dimension coordinate system. Position vector of a point in 2D. In 2D, one thing is very clear. In 2D, one thing is very clear. This point, say P has coordinate x, y. Then we can join these are two coordinate axes. Origin is well defined, the point of intersection of two axes. We can join O to P easily. This is going to be the position vector. We need not consider any other origin, since O is well defined origin in two-dimensional coordinate system. So it will be enough to say, enough to find the vector OP. And this all can be, you just draw a perpendicular here. PM is the perpendicular drawn. This is X, this is Y. So OP equal to what? R, that is position vector of P. This is xi plus yj. We have done it before. In 3D, what we have done? In details it is done. R vector going to be xi, yj, zk. And these I and j are unit vectors. And if 3D is there, k is the unit vector along z axis. Mod r, we have seen root over x square plus y square. But instead of finding modulus, it is more important. It is more important to solve problems just by using the concept of position vector, and keeping in mind that there is a origin or there is a starting point. From there, if we join, it will be the position vector of the point. We need not draw origin always. This I have told you earlier also. isn't it? Now, suppose you want to find the vector joining 2 points. 3D representation we did before, model you all know it, and direction cosines also we have done. Now the problem is to find the direction ratio and direction cosines of the vector joining these 2 points. A and B are 2 points given. You have to find the DCs, DRs and DCs of AB. So what you will do here first, you will find AB vector. AB vector is what? Position vector of B minus position vector of A. Position vector of point whose coordinate x, y, z is given by this. So here position vector of B will be what? x2 I cap, y2 j cap, z2 k cap, x1 y1 z1. Okay, so this is going to be x2 minus x1 I cap, y2 minus y1 j cap, and z2 minus z1 k cap. Okay, so AB vector you got. If you take this one as A, this one as B, scalar, this one as C, then AB vector going to be what? AI BJ CK. A is x2 minus x1, and C vector is z2 minus z1. Okay, so direction ratios you got x2 minus x1, y2 minus y1, z2 minus z1. Direction cosines, how will you find? The formula you got in the first session, that DCs are what? L equal to A by under root sigma A square, B by, and n equal to ABC you got here, you just write x2 minus x1 divided by under root y2 minus y1 whole square plus, okay, similarly this will be y2 minus y1 by under root by sigma. So these are just basic concept of vector up to section formula, direction ratio, direction cosines. Whatever you have done, this belongs to basic concept of vector in 3D in class 12 mathematics. Now this is the time to find some easy application of the concept. Let us find the unit vector in the direction of sum of two vectors. Sum of two vector means corresponding components will be adding. Component of first one 2, 2 minus 5 along x, y and z axis, and this one 2, 1 and 5 unit. So A plus B going to be what? 4i 3j. Simple. So required unit vector will be what? A the vector divided by its modulus. So there it will be 4i 3j divided by so 4i plus 3j by 5. Clear? 0.8i 0.6j. Okay? So this is the required unit vector. So that the following points are vertices of a right angle triangle. Any triangle is there. To prove it right angle, we need length of 3 sides, and in this chapter we will be doing with the help of vector concept. You might have experienced in class 11 theory the distance formula you have used. We will be doing the same thing but with the application of vector. So what you will do here, you will find 3 sides AB vector. This is position vector of B. So B is what? I minus 3j minus 5k is 2i minus j plus k. This is nothing but minus I minus 2j minus 6k. So you got AB vector. Okay. BC vector, similarly position vector of C. If you are answering your descriptive question paper in school or board, you have to show these steps. Okay. Position vector of C will be 3i minus I 3j to I minus j plus k. Okay. So BC vector you got, and then let us find AC vector or CA vector. CA vector will be what? Position vector of A, 2i minus j plus k minus position vector of C, 3i. So that will be minus I 3j 5k. Okay. Now let us find the modulus of these 3 vectors. Mod AB is what? We want to see whether Pythagoras theorem available or not here. Satisfied or not. This will be under root. Just modulus of the vector. Root 41. Mod BC is 411. And mod CA is what? 1925. Root 35. Okay. So what have you got there? You got AB vector, BC vector and CA vector. If you take this one AB, this is root 41. AC vector is length is root 35. So Pythagorean theorem is valid. Hence, these are 3 vertices of a right angle triangle. And this is the time to write the answer. Find the direction cosines of the vector joining this and this. Just we have done it. I think I need not do it. Isn't it? You will just write the vector AB here, B minus A, that is minus 2i, minus 4j and 4k. So drs of AB are what? And this is our what? 2 by 6 because 4 square, 2 square also there, root 36, that is 6, minus 4 by 6 and 4 by 6. These are the direction cosines. Okay. Now the problem is to find position vector of a point R which divides line segment joining two points P and Q respectively in the ratio 2:1 internally. 2 and this part is 1. Very simple. P is position vector given 2i and Q also, you know, 4i. So position vector of A will be what? 2 into 4i that divided by 2 plus 1. So it will be 10i plus 9j 16 plus 4. Okay. So you got position vector of the point A which will divide it internally in the ratio 2:1. For externally you just put a minus sign over there. If B divides PQ externally in the ratio 2:1, sorry, these are P and Q, not AB, whatever. PQ and B divides in such a way that PB is to QB equal to 2:1. You just change the sign over there. Position vector of B will be what? External division. Like internal one, we can prove it for external one also. It will be 2 into position vector of B. B is what? That is 4i minus position vector of A. This is what? 2i (4k) that divided by 2 minus 1. 8 minus 2, that is 6i, 12 plus 3, 12 plus 3, 15j, and minus 16 minus 4 minus 20k. Bus. This way you can find it. Okay. How to prove that the following points are collinear by vector method? If you are doing it in class 12 descriptive paper, your boards or school examination, then learn the way how to answer. You cannot solve it like MCQ, no? You have to write. So these are 3 points, A, B and C. You don't know if collinear or not, I have taken. How to prove it that they are co-linear? 1, 2, 7. Which calculation in vector will show you that they are collinear? 2 ways are there. You prove that, you find 2 of the 3 vectors. What are the 3 vectors here? AB, BC and AC. These are 3 vectors in the same direction. If you can prove that one of them is the scalar multiple of the other, then it's fine. Because collinearity is a special case of parallelism. If you can prove that one of the vectors is the scalar multiple of the other, then it's fine. So how to find it? You find AB vector. AB is what? Position vector of B minus position vector of A. That is I, 4j, you understand? and AC vector is what? Position vector of C, 3 minus 1, that is 2, 10 minus 2, that is 8, minus 1 minus 7 minus 8. Okay. Can you prove that AB is a scalar multiple of AC or opposite? AC is a scalar multiple of AB? Yes, yes, we can do it. Just write this one as 2 into I cap 4 j cap so what do you get? AC vector is twice AB. So what does this imply? Therefore ABC are collinear. Clear? Hope you have understood. Now another type of problem which you have done in theory but using vectors. It is specified and you will find understanding will be easier for you to prove it with the help of vector. They are collinear given. Find the ratio in which B divides AC. Purely section formula method. You assume that when A and B are points, no, A and C are the points, and then B divides it in the ratio m is to n. Or you can take lambda is to 1. It's up to you. Isn't it? That m by n, if we replace by lambda, then one can assume that the ratio will be lambda is to 1. Now, what do you get there? That position vector of B you can write, position vector of A you can write, C also you can write, isn't it? So you assume it this way, let B divides AC in the ratio what? Lambda is to 1 or m is to n. Same thing, you take lambda is to 1, no problem. Comparison will be easier. Then position vector of B is what? That is 5i minus 2k. Position vector of A is what? I and C is what? 11i, 3j, 7k. Okay? Now B vector, position vector of B, 5i plus 0j minus 2k will be, you have taken the ratio lambda is to 1, it will be lambda into 11i 3j 7k plus 1 into A vector. A vector is what? That is I minus 2j minus 8k, that divided by lambda plus 1. Okay? So if you get the unique value of lambda, then it's fine. How to? That 11 lambda plus 1, you take all I cap together, 3 lambda minus 2 j cap and 7 lambda minus 8 k cap. Okay? That by lambda plus 1. So you just compare two sides. Two vectors are equal. They are equal in all respect. That 5 will be equal to comparing 5 will be 11 lambda plus 1 by lambda plus 1. 0 will be 3 lambda minus 2 by lambda plus 1. and minus 2 will be 7 lambda minus 8 by lambda plus 1. It will be good if you find lambda here, 2/3. If you put lambda 2/3 here, then these two satisfy, then it's fine. Otherwise it will not divide. For lambda equal to 2/3, what you get here? For lambda equal to 2/3, RHS for this 22/3 plus 1 by 2/3 plus 1, that is 25/5. It is 5, and here 5 equal to 5, satisfied. Here for lambda equal to 2/3, RHS is so what you get there? It is going to be 14 minus 24, that divided by 5. For a descriptive question, you need to check whether the remaining two conditions are satisfied with this or not. Okay? Even for some MCQ questions, you may be confused to see different values of lambda. Be careful. Thank you. Next session I will be discussing more problems and dot product, cross product, all these will come one by one. Okay?